x to the power of 3 equals 6 to the power of x. Then let's have it to the solution. Of course, this is exponential equation. So from here, let's introduce log. When we have ln of x to the power of 3 equals ln of 6 to the power of x. But remember that when we have ln of p to the power of m, this power m will come down to base as m multiplied by ln of p. So when we apply to this and this power 3 will be 3 times ln of x equals this power x will be x multiplied by ln of 6. So from here, let's divide through by x. Then let's divide through by 3. So from here, this will be equals ln of x divided by x equals ln of 6 divided by 3. So, having known this one, let us recall that when we have 1 divided by a to the power of n equals a to the power of minus n, this will change to negative. But this one has power 1, so we can have this as ln of x multiplied by this x to the power of minus 1 equals ln of 6 divided by 3. Then let us also note that when we have e to the power of ln of a equals a, so definitely when we have e to the power of ln of x to the power of minus 1, will give us x to the power of minus 1. So let's put it here. We have ln of x multiplied by, instead of this, we replace it with this. E to the power of ln of x to the power of minus 1 equals ln of 6 this divided by 3. So from here, this will come down to base. We're going to have ln of x multiplied by this power will come down to base as minus 1. Then ln of x equals ln of 6 divided by 3. Then we want to do some manipulation here by making sure that this power equivalent to this base, but this power has negative, here is not. So let's multiply through by minus 1. Here will be minus into ln of x multiplied by e to the power of minus ln of x, we close it, equals ln of minus here, ln of 6 divided by 3. So from here, when you open the bracket, here will be minus ln of x multiplied by e to the power of minus ln of x equals minus ln of 6 divided by 3. Then there's something we call W Lambert function that says when we have y to be equals alpha multiplied by e to the power of alpha, then the W Lambert function of this y will be W Lambert function of y equals the W Lambert function of alpha multiplied by e to the power of alpha. Mind you that this will give you back your alpha. Why? Because so far the base and the power are the same. The output will be either of the one. So therefore, we want to apply this W Lambert function to this side of this expression and to this side. So meaning we are going to have the W Lambert function of minus ln of x multiplied by e to the power of minus ln of x, as this will be equals to the W Lambert function of minus ln of 6 divided by 3, as this. So by applying the expression of W Lambert function, here is alpha, here is also alpha, meaning that the base and the power are the same. So check here, the base and the power are the same. So definitely here will be minus ln of x equals the W Lambert function of minus ln of 6 divided by 3, as this. So the next thing we can do to avoid this negative is to multiply through by negative. When we multiply through by negative, then we are going to have this as negative outside, minus ln of x in parentheses as this, equals minus W Lambert function of minus ln of 6 divided by 3. So from here, here will be ln of x equals minus the W Lambert function of minus ln of 6 divided by 3. So to avoid this natural log, we can take the exponent of both sides as e to the power of ln of x equals e to the power of minus w Lambert function of minus ln of 6 divided by 3. So from here, this we cancel this. We have x to be equals e to the power of minus w Lambert function of minus ln of 6 divided by 3. So this is value of x, or we can express this as when we have the W Lambert function of alpha multiplied by e to the power of alpha always equals alpha, and also equals the W Lambert function of alpha multiplied by e to the power of W Lambert function of alpha. So from here, it is obvious that this as associated with the formula to the power of W Lambert function of alpha will be equals alpha divided by the W Lambert function of alpha. So when we apply it to this, we realize that the whole of this time can be simplified as 1 divided by e to the power of W Lambert function of minus ln of 6 divided by 3 as this. So we're going to have this one here to be x will be equals 1 divided by the W Lambert function, that is will be minus ln of 6 divided by 3 again divided by the W Lambert function of minus ln of 6 divided by 3. So this one will go up. So we're going to have x minus W Lambert function of minus ln of 6 divided by 3, then divided by ln of 6 divided by 3, and this can be simplified as minus 3 W Lambert function of minus ln of 6 divided by 3, then divided by ln of 6 to be the value of x. So when you check this solution, you will realize that no real solution for this. It's a complex solution. Even to check graphically, we have x to the power of 3 equals 6 to the power of x. So let's consider this graph. So we have 6 to the power of x. When we have 6 to the power of x, assuming 6 to the power of x located around this place, so we are going to have something like this for 6 to the power of x. So likewise, when we also have x to the power of 3, the graph of this normally located as this. So meaning that we have this to be x to the power of 3. So from here, we will see that no point of intersection for these two lines, no point of intersection. If there's no point of intersection, meaning there's no real solution. No real solution for this. So if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. Bye-bye. Bye-bye.